Good morning, students. Am I audible? Good morning, all of you. Am I audible or not? Anjan?
Yes, sir. Good morning, sir.
Good morning. Just wait 2 to 3 minutes, then we will start the session. Day, we already covered the topic that is the decoder. Okay. So first, we will discuss the encoder and the priority encoder and the parity checker. Then we will move forward for the flip-flop part, the sequential circuit. Okay. So first is the encoder. So what is encoder? So encoder actually is a digital circuit that performs the inverse operation of a decoder. You already know the concept about the decoder. So this process, in the case of decoder, the process was that the decoding, but here the process is that the encoding. Okay, so this is the opposite of decoder and the process is called encoding. So here in encoder, actually this is a combinational logic circuits, and it converts the active input signal into the coded output signal. So for the case of encoder, suppose it may have input lines, and here only one of which the active at any time and m output line. Okay, so in encoder, the number of output is less than the number of input. So here one thing I am drawing the block diagram of encoder. So like that, uh, suppose. Okay. So this is in input and this is m output. Okay, and here the number of output is less than the number of input, means n greater than m here. Now there is a concept of the octal to binary encoder. Actually, in your syllabus there is a concept that only mention the encoder part. So this is the encoder, but here uh, the octal to binary encoder, decimal to BCD encoder, these are the thing, and the priority encoder. So as per my opinion, the priority encoder is important for your exam, but here I will actually discuss octal to binary as well as the primary encoder. Okay, priority encoder. So first I will discuss that is the octal to binary encoder. So what is octal to binary encoder? This is octal to binary encoder. So for the case of octal to binary encoder, there is 3-bit input. Okay, there is 3-bit input, and it activates one of the 8 output because lines corresponding to that code. Okay, and it accepts the 8 inputs and produce the 3-bit output code corresponding to the activated input. So for the case of octal to binary encoder, you have to know the truth table. So with the help of truth table, you can easily construct the octal to binary encoder. So what is the truth table? Truth table of octal to binary encoder. I am here writing. The problem is that every time I am getting, some of you are waiting room. Okay, so after 10 to 20 minutes, I will not give you access to enter because it disturbances to continue the class. So truth table is that suppose the input here that is D0, D1, D2, D3, D4, D5, D6 and D7. The output is that here, sorry, Y2, Y1 and Y0. Zero, 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 1, 0, 0, 0, 0, 1, 0, and this is 0, 0, 0, 0, 0, and 1. And here, this is 0, 0, 0, 1. This is 0, 0, 0. Sorry. 0, 1, 0, 1, 0, 1. Okay. So here, actually, this is the truth table for the octal to binary 3:8 decoder. Okay, so it accepts the 3-bit input code and activates one of the 8 outputs line corresponding to that particular code. And here the octal to binary encoder performs the opposite function. Opposite function means here it accepts the 8 inputs and produce the 3-bit output code corresponding to the activated code. So in the case of decoder, in the case of decoder, you just saw the opposite truth table. Opposite means in that case the input was ABC are 3 inputs, and the case of output there is 8. But in the case of here you can see the opposite of the decoder. Okay, so from this you can easily construct the expression for Y0, Y1 and Y2. So for the case of I am here writing in the upper portion, suppose for the case of Y0. So for the case of Y0, for the case of Y0 from the truth table, you can get that Y0 equals to D1 plus D3 plus D5 and plus D7. So how I am getting this? because from the truth table you can see that y0, that is the LSB of the output code, must be 1 whether the whenever the input D1 or D3 or D5 or D7 is high. I means 1. So that's why Y0 equals to D1 plus D3 plus D5 plus D7. Similarly, for the case of Y1, similarly, for the case of Y1, it is D2 plus D3 plus D6 plus D7. And for the case of Y2, it is D4 plus D5 plus D6 and D7. So we already got the expression of Y0, Y1 and Y2. Okay, so from this expression, the octal to binary encoder can be implemented using the 3-4 input OR gate. So how it will implement? So I am here. I will design the octal to binary encoder using the 3-4 input OR gate. Okay, so I am erase these things. I am erasing these things. Suppose it is like D0, D1, D2, D3, D4, D5, D6, and D7. Okay. Like that. So I got the expression. So I got the expression already for the Y0, Y1, and Y2. So for the case of Y0, I am here again writing. For the case of Y0, it was D1 plus D3 plus D5 plus D7. For the case of Y1, it is D2 plus D3 plus D6 and D7. And for the case of Y2, it is D4 plus D5 plus D6 and D7. Okay, so one thing you should remember, whenever we are drawing the circuit, in that case the design in such a way that when the D0 is high, in that case the binary code 000 is generated. When D1 is high, in that case the binary code 001 is generated, like this. Okay, so here for the case of, suppose I am here drawing the first Y0. So Y0 means D1, D3, D5 and D7. Okay, so this is D1. Next D3. D5 and D7. So this is Y0. So for the case of Y1, that is D2, D3, D6, and D7. And next is 4, 5, 6, and 7 for Y2. So this is so here you can see this is the three OR gate, that is y here for the case of y0, y1, and y2, and for these three OR gate there is 4 input. All of this gate having the 4 input. Okay, so this is the for the case of octal to binary encoder. This is octal to binary encoder. Here actually the design is made simple by the fact that one by the fact that only the 8 out of the total of to the power 8 possible input conditions are used. Okay, so this is the thing for the case of octal to binary encoder. Next the topic is that the priority encoder. What is priority encoder? So before going to discuss the priority encoder, is there any doubt for the octal to binary encoder?
यहाँ पे Y1 में लास्ट में D7 है ना सर, ड्राइंग में D6 से किया है।
कौन सा?
यहाँ पे जो किए है ना ऑक्टल टू बाइनरी इनपुट Y1 में लास्ट वाला सर D7 से होगा ना।
हाँ हाँ, एक गलती हो गया, ठीक सही, ये वाला है, ठीक ठीक ठीक, y1 का तो ये वाला यहाँ से कनेक्ट होगा, ठीक है, एक मिनट। Sorry, I think now it is okay. Yes or no?
Yes, yes sir.
Okay, thank you. So next we will discuss that is the priority encoder. Before going to discuss the priority encoder, first I am here drawing the truth table for 4 input priority encoder. So if I draw the 4 input priority encoder here, so it is very easy to understand the concept about the priority encoder. So first just giving a few seconds to draw the truth table. This is the inputs and this is the outputs. This is D0, this is D1, this is D2, and this is D3. Suppose and this is Y2 and Y1 and P. Okay, so this is the truth table for normal the 4 input parity encoder, and there is a variation, that is 8 is to 3 parity encoder, decimal to BCD parity encoder, like that. Okay, but this thing actually I will not cover. Actually, mainly we will give you the concept about the what is the priority encoder. Okay, so you have the concept about the encoder as well as the decoder. So here the priority means, suppose I am giving, suppose there is 4 members, but out of 4 members I am giving some person the priority. Okay, so mainly the priority concept is takes place in this priority encoder. So the priority encoder is an encoder that includes the priority function. Okay, so the operation of priority encoder in such a way that if 2 or more inputs are equal to 1 at the same time, then the input having the highest priority will take precedence. Okay, so suppose that 2 or more inputs are equal to 1 at the same time. So in that case, the input having the highest priority will take the precedence. So here, one thing here, you are watching that some portion I have written that XX. So this X are the don't care condition. So in particular, this condition designated the fact that the binary values they represent may be equal to 0 or 1. Okay, so this actually values X denoted or here, it may be 0 or maybe 1. So suppose there is four input, so that is D0, D1, D2, and D3. So out of this, the input D3 has the highest priority. Okay, so when this input is 1, so here you can see here in the D0 only, here the input is 1. So corresponding output, the corresponding output, what we are only considering the Y2 and Y3, and the rest I will tell you what is V. Okay, so here for the case of D3, D3 has the highest priority, and here the input 1, when input 1, so the output is Y2 and Y1, that is 1 1. So D3 1, when output Y2 Y1 is 1 1. For the case of the next mm, priority level, that is D2. Next priority level, that is D2. So here D2 is 1. So in that case, the output is 1 0. So Y2 means this is 1 here. This is 1 here for the case of D2. So corresponding the output is 1 0. So next priority level, that is D1. So for the case of D1, the output is 0 1. Just wait. I'm requesting all the participants write your name in the chat box for the attendance for the first session. Okay. I'm requesting again, but at this moment there is 26 students, but I am getting here only 22 response. If your response is not collected here, so you will not get the attendance after the session. There is one thing that I have said that D3, the highest priority level, when the output uh, for the case of the input is 1, so output is in that case y2 y1, that is equals to 1 1 3. So the next is the D2 the next priority level. In that sense the output is 1 0. In that sense D2 equals to, if D2 equals to 1 and D3 equals to 0, and just and the output for the case of D1 is generated only if the higher priority inputs are 0. Okay, so here actually uh, mm, the output for the case of D1 generated only if the higher priority inputs are 0. So on the down the priority level, one thing, and here just and one thing that there is a you can see there is a column that is the V. What is V? V is the valid output indicator. Valid output indicator. So if all the inputs are 0, in that sense V is equals to 0. Okay, so if all the, suppose you are considering that the first inputs, that first all the inputs are 0, in that sense it is 0, and if the all the input is not 0, in that sense it is 1. That's why first there is 0 0 0 0, there is 4, so correspondingly the V is indicating 0, but the rest of the 3 there is in any case there is 1, so that's why V is indicating the rest of the cases 1. Okay, so this is the priority encoder concept, and in the next session, actually after this session the time is almost over. In the next session actually we will discuss, that is the parity generator and the parity checker, and then we'll discuss the flip-flop and latches. Okay, so if we started here the flip-flop and latches, so the module 4 we will start today. Okay, no issue. So okay, so I'm just ending the session here, and after 5 to 6 minutes you will join with the same link. Okay, thank you.